Hi, this is Margo. This is Sunday late afternoon, October 15th, 2023. I hope everyone is safe and doing as well as possible. And another week has flown by, and I'd like to welcome everyone to the show tonight. This will be my weekly update that I'll be putting on YouTube, where we'll go over climate-related items and methane and sea ice and some other things. And I'd like to apologize for not being able to do my full show last week. I just had a rough week and wasn't feeling well, and so I just did the methane update. And thank you all for your kind comments and well wishes, and I had a better week this week, and so I'll be able to do a full show tonight. So I'd like to start out with an article. This is off of Sam Carana's website, arctic-news.blogspot.com, and he posted this on Friday, so it's his latest post, and he the title says temperature rise September 2023 and beyond. And this is a pretty detailed post. He goes into a lot of different aspects, and I'll leave the link below, but I'm going to go over some of this because it's important for us to keep following on a month-by-month basis. It's like every month is the hottest on record for that one for the year. So we had it again. And so this is temperature anomaly of 1.49. I guess that's Celsius. Here's his chart down here, and the dark area is a range between 4.0 and 10.4, higher than normal. And so we're seeing that here over western Russia, and down all the way to France, it looks like. Also northern Canada, and over the Arctic basin, and looks like most of the Antarctic is covered with that highest range. So let's see what he says. The above image adapted from NASA, and the image below adapted from Climate Reanalyzer, and using the same baseline, illustrate the September 2023 temperature anomaly. And so here's Climate Reanalyzer, and you're seeing all these reds and even up into the pink zone over the Antarctic. So it really heated up this last month. And the pink and moving into the white, the highest is like 20 C higher than normal. So this is 2-meter temperature anomaly for the month. So, and he says September 2023 was the month with the highest temperature anomaly on record. What contributed to this? And then he starts going through all the factors, and he starts with El Nino. The temperature rose about 0.5 degrees C from November 2022 to March 2023, and this occurred at a time when we were not even in an El Niño yet, as illustrated by the above image from an earlier post. Below is an updated image from January 1950 to September 2023, adapted from NOAA. So here's the image, and if we click on it, see, here's the highest up here at the very end. And so here's our temperature that's going steadily up, but look at the last few years. So here's this year. Alright. I gotta scroll back down. I lost my place. And then this image also has the anomaly. The current El Niño is still strengthening, as illustrated by the image on the right. Further contributors. There are further reasons why the temperature can be expected to keep rising beyond September 2023. The number of sunspots has been higher than predicted and looks set to keep rising above predicted levels until July 2025. The eruption of the submarine volcano near Tonga in January 2022 caused a lot of water vapor to reach high up into the atmosphere, and this may still contribute to the temperature rise. Aerosols that have a cooling effect, such as dust and sulfates, or SO4, are also important. As fossil fuel is burned, sulfates are co-emitted. Since they pollute the air, measures have been taken and are being taken to reduce them, e.g. in shipping, and this has pushed up the temperature rise. That's caused there's not as many sulfates going into the atmosphere to block the sun. Meanwhile, cooling aerosols such as sulfates are still high, as illustrated by the image below. SO4 was as high as 8.621 something T at the green circle on October 6, 2023. In future, SO4 could fall dramatically, e.g. in case of sudden economic collapse, reducing the aerosol masking effect rapidly and abruptly, causing a substantial rise in temperature. So, he's looking at this area. That's China. That doesn't, see, China's high, the highest polluter on the planet, but no one wants to say that. After little change in the Antarctic sea ice extent graph for decades, extent loss was dramatic in 2022 and even more dramatic in 2023, as less and less sunlight was getting reflected back into space and instead was getting absorbed by the water of the Southern Ocean. And I've been showing this every time I show sea ice. Here we are. I mean, this is record low. All year it was record low. Sea ice retreat comes with albedo loss, resulting in more heat getting absorbed in the Southern Ocean. A warmer Southern Ocean, in turn, comes with fewer bright clouds, further reducing the amount of sunlight reflected back into space, while albedo loss may have made little difference during winter in the southern hemisphere. When little sunlight reaches the sea ice around Antarctica, open oceans are less efficient than sea ice when it comes to emitting in the far infrared region of the spectrum. Over time, however, albedo loss matters a lot. The white band around minus 60 degrees south on the image below, adapted from NASA, indicates that the Southern Ocean has long been colder than oceans elsewhere, but is catching up with the global temperature rise. For decades, there still were many lower clouds over the Southern Ocean reflecting sunlight back into space, but these lower clouds have been decreasing, further speeding up the amount of sunlight getting absorbed by the water of the Southern Ocean. A recent study points out that this pattern effect could make a huge difference globally. The image above also illustrates that anomalies are highest in the Arctic, narrowing the temperature differences between the Arctic and the tropics, with the airflow slowing down accordingly. This in turn changes the jet stream and the polar vortex, resulting in blocking patterns that can, in combination with rising temperatures, strongly increase the frequency, intensity, duration, and area coverage of extreme weather events such as storms and lightning, heat waves, and forest fires. And we've seen that with the broken jet stream. Forest fires in Canada have been releasing massive amounts of emissions that push up the temperature, including greenhouse gases such as carbon dioxide, warming aerosols such as black carbon and brown carbon, and NMVOC, or non-methane volatile organic carbon, and carbon monoxide that reduce the availability of hydroxyl, resulting in more methane and ozone in the atmosphere. Well, I haven't seen more ozone, unless he's talking about bad ozone. At the same time, slowing down of the AMOC, or Atlantic Meridional Ocean Current, can result in more ocean heat accumulating at the surface of the North Atlantic. As temperatures rise, increased meltwater runoff from Greenland and more icebergs moving south, in combination with stronger ocean stratification and stronger storms over the North Atlantic, can also cause a freshwater lid to form at the surface of North Atlantic that can at times enable a lot of hot water to get pushed abruptly underneath this lid toward the Arctic Ocean. The danger is that more heat will reach the seafloor and destabilize methane hydrates contained in sediments at the seafloor of the Arctic Ocean. Ominously, very high methane levels continue to be recorded at Barrow, Alaska. And here's the methane there. This is, see, here's 2,400 parts per billion. And so it's still high up there. I'm wondering I guess this is at surface level. That seems about right. The next few months will be critical as Arctic sea ice is sealing off the Arctic Ocean from the atmosphere, trapping heat underneath the ice and making it harder for ocean heat to get transferred from the Arctic Ocean to the atmosphere above the Arctic. Furthermore, sea ice is very thin, reducing the latent heat buffer that could otherwise have consumed ocean heat. The next danger is that the thin Arctic sea ice will rapidly retreat early next year, as a warming Arctic Ocean will transfer more heat to the atmosphere over the Arctic, resulting in more rain and more clouds in the atmosphere over the Arctic, speeding up sea ice loss and further pushing up the temperature rise over the Arctic, as discussed in the feedbacks page, which also discusses how less Arctic sea ice can push up temperatures through the emissivity feedback. As temperatures rise over the Arctic, permafrost on land also threatens to thaw faster, threatening to cause huge releases of greenhouse gases, including carbon dioxide, methane, and nitrous oxide. Meanwhile, emissions of greenhouse gases keep rising, further pushing up the temperature. There are numerous further feedbacks that can accelerate the temperature rise and tipping points that can get crossed and cause even more abrupt rise of the temperature. One of these is the clouds tipping point that in itself can cause a temperature rise of 8 degrees C. Further feedbacks are also discussed at the extinction page. A warmer atmosphere holds more water vapor at a rate of 7% for each degree Celsius. The temperature rises. As temperatures keep rising, even more water vapor will be sucked up by the atmosphere. This will also cause more droughts, reducing the availability of land to sustain vegetation and provide soil cooling through shading and through evaporation and formation of lower clouds. More water vapor in the atmosphere will also speed up the temperature rise because water vapor is a potent greenhouse gas. This makes it critical to assess how much the temperature has already risen. NASA data up through September 2023. The image below, adapted from NASA, shows that the September 2023 NASA land and ocean temperature was 1.78 degrees C higher than it was in September 1023. So that's in 1,000 years. The anomaly is 1.74 degrees C when compared to a base centered around the year 1900. The 1.74 degrees C anomaly can be adjusted by 0.99 degrees C to reflect a pre-industrial base, air temperature, and higher polar anomalies, adding up to a potential anomaly of 2.73 degrees C. So you can see it's been going up, and here we are, the latest, higher than before. Indeed, earlier analysis points out that the temperature may already have risen more than 2 degrees C compared to pre-industrial in 2015, when politicians pledged at the Paris Agreement to take action to combat the temperature rise to prevent this from happening. The above image is created with NASA Land plus Ocean Monthly Mean Global Temperature Anomalies, adjusted by 0.99 degrees C to reflect ocean air temperature, higher polar anomalies, and a pre-industrial base, and has trends added. Conclusion. Alarm bells are sounding loud and clear. They've been sounding loud and clear for a long time, as discussed in posts such as this one, warning that the temperature could rise by more than 3 degrees C by 2026. The above magenta graph shows how this could occur as early as next year, by the end of 2024. The precautionary principle should prevail, and the looming dangers should prompt people into demanding comprehensive and effective action to reduce the damage and to improve the situation. To combat rising temperatures, a transformation of society should be undertaken along the lines of this 2022 post, in combination with the declaration of a climate emergency. So I'll leave the link below. So he puts everything together here and lists all the, well, not all, but the main potential feedbacks for the consequences of this continual rise, and this is, you'll see how this backs up my methane report tonight as well. So thank you, Sam Carana, for that most informative blog post, and we'll keep tuning back in for more good posts from him. Alright, now we're going to start over here on Climate Reanalyzer for today with maximum temperatures around the planet. These are air temperatures at 2 meters, and here we've got pretty cold air over Greenland and creeping up over the Arctic basin. The bright purple is like 30 degrees C, or minus 30 degrees C. That's, in the negative there. And then blues around that. And then we still have a lot of greens, which is above freezing. This dark green is about 5 degrees C. This is over this North Atlantic, and coming all the way around Russia, and on this west side too we've got greens. And then we've got the greens, which is really colder air for the US, see, coming down through Canada and the US, and we've got warmer air coming in on the desert southwest now. And here in the Reno area, we had some colder temperature this last week, and now it's warmed back up. We're having cool nights. We had our first hard freeze a couple of nights ago, and so it's still cool nights, but the high today was 81 degrees. And so that's about 10 degrees above normal this time of year. And so this week is going to be in the 80s and 70s for the highs, I think. And so there's that. Here's the flat view, and we're seeing all these whites across Brazil and Ecuador, Peru, Bolivia, and anyway, moving down further south in South America. Whites across Africa, Northern Africa, Saudi Arabia, and just below Central Africa, or maybe, just below the Congo here. Here's some white in West India. Australia, you've got whites on the whole west side and white denotes 40 degrees C or higher, or about 104 degrees Fahrenheit or higher. Here's 2-meter temperature anomaly, and we can see the blue over most of Greenland, and blue, which is colder than normal, over a lot of this Arctic basin, but we've got browns just around that, and heavy brown over the Beaufort Sea and this East Siberian Sea, light brown over the east side here, and we've got reddish brown over northern Canada. And then that dark reddish brown, that's about 14 to 15 degrees C higher than normal here. Then browns across, and then look at the blues. Cold air, colder than normal, coming down through the Midwest, through Texas and all the way east, and then browns everywhere else. Here's the flat view, and see now Europe. You're in the blues, UK, Scandinavian area, but Spain, you're still in the browns. Western Russia is in the browns. Most of Russia, it looks like, is in the browns. The little bit of blue over Siberia. Lots of browns coming across here. And in the Antarctic, it's reds and browns. Here, this is on the west side, just north of the Weddell Sea, on the west side. I think, yeah, here's the Western Peninsula. So this is north of that. Here's our overview. Worldwide, we're up 0.9 C, higher than normal. The northern hemisphere is up 1.3 C. The Arctic is up 2.61 C. The Antarctic is up 0.57 C. Southern hemisphere is up 0.5 C, and the tropics are up 0.92 C. So everything's in the plus zone. It's all higher than normal. But you know, this world at 0.9 and tropics 0.92, that's real close to 1 C higher than normal. So these four are the big ones there. Here's precipitation and clouds. The green is rain, the blue is snow. You can see it's raining near Iceland and then snowing. It moves into snow. As you go up, we've got snow on the west side of Greenland, and also rain and snow here next to Norway, and then snow here over the Barents Sea, and then rain coming up in Russia, and then snow in central Russia, then snow over this East Siberian Sea and Laptev Sea, and snow over the Beaufort Sea, snow in Alaska, and then rain. And these systems are just coming across now, and this is the beginning of these atmospheric rivers that are being set up to come across. And here's our last one that just is coming off of the continent here and getting ready to go across the Atlantic. Here's the flat view, and we can see right down here we've got snow coming up to the coast of the Arctic, But then a little further out, see the pink is rain-snow mix. Or freezing rain, yeah, freezing rain. There. So pretty warm for to have freezing rain, and that's where some of the sea ice, the edge of the sea ice is. And here we can see the Pacific with one after another coming across the Pacific. And then here's what is left of the jet stream, the pieces. We can see the breaks and cold air coming down, and then warm air further south here on the west side. You know, it looks like we could get a heat dome set up, heat dome situation set up that could last for a while, like we've seen before. And we've got double lines here in the northern hemisphere and also in the southern hemisphere. We've got double, triple lines in some places. And we'll look at sea ice in a minute. Here's sea surface temperature anomaly. This is for yesterday, the 14th. And we can see that these browns are starting to dissipate as the sun's going down, and so the water is cooling off. It's still pretty high though, and it'll take a while for all of this water to cool down. It's been in the sun for so long. So we've still got browns over parts of the Arctic Ocean there. Hudson Bay is still brown and red. And here's our hot spot just off the coast of Canada here, and this is Newfoundland right up there. And pretty almost totally solid brown in the Gulf of Mexico. We've got colder water here off the coast of North America. And here's a spot in the central Atlantic where it's colder. But generally it's in the browns. We can see in the Mediterranean we've got reddish brown and brown there. And the reddish brown, that's about 4 to 5 C higher than normal there. Persian Gulf is still in the brown. The Red Sea is brown. Indian Ocean is mainly brown. In the Pacific, here's this hot spot right around the equatorial Pacific coming across. And our evil mouth blob here in the Northwest Pacific has kind of dissipated, and looks like it's kind of broken up and moved east a little bit, but we'll see. And it looks like, and it's red. It's in the red zone between Japan and the mainland there. So there's that. Now we'll look at methane. Now I have 2 days worth of NOAA methane data I need to go over. So we're going to look at Friday and Saturday from NOAA, and then just Saturday for the CAMS methane data. So we're starting here on Friday the 13th. Met-Op-B satellite in the morning, 1000 millibar level. The mean or average was 1843 parts per billion. In the afternoon it was 1844. On the Met-Op-C the mean was 1851 in the morning, and in the afternoon it was 1845, so pretty good spread there. On 487 millibar level, Met-Op-B in the morning, the mean was 1923, and we have a high reading of 2533. Normally we don't see it up to 25. In the afternoon the mean was 1928. On the Met-Op-C in the morning the mean was 1898, and in the afternoon it was 1892, and our high reading spiked to 2003.23. So that's a higher reading than we normally see here, and we can see almost the whole northern hemisphere is in the pink zone, and that's a range between 2000 parts per billion and whatever is the highest number here, the 2333. And then for the 14th, or Saturday, Met-Op-B satellite in the morning, 1000 millibar level. The mean was 1843. In the afternoon, it was 1845. On the Met-Op-C in the morning, the mean was 1857. And in the afternoon, it was 1851. On the 487 millibar level, Met-Op-B in the morning, the mean was 1924. And again, we have a high reading of 2549, so another spike there. And in the afternoon, the mean was 1927. On the 487 millibar level, well, we're on 487. Met-Op-C in the morning, the mean was 1904. And in the afternoon, it was 1898. So, we normally don't see it above 1900 here on this reading. 1898. So, fasten your seat belts here. So, for our weekly chart, we're starting with just the Met-Op-C satellite for 487 millibar level. And the 14th average was 1901.0, and that was an increase this week of 7.5. And look at that, it just zipped right up. It's unbelievable. I mean, it went up in 1 week halfway what it would do, or more than half of 1 year, really, in 1 week. So that's pretty severe there. So let's see what happened here this week. So here's where we ended last week. We ended at 1893.5 for October the 7th, and we had gone down last week 1.0, and then the 8th went up 2.0, so it's going up. The 9th up 4.0, and I put some question marks here because there was quite a bit of missing data on one of the readings, and so I didn't want to just totally count this. You know, if it was going to be our high reading, I really didn't want to count that. And then the 10th went down 4.0. The 11th went down 1.5. The 12th, no change. The 13th up 1.0. And then on the 14th, it jumped up 6.0 in one day. 6.0. So there must have been a blowout somewhere. That's all I can think of. And so we ended the week at 7.5, higher than normal. I mean higher than last week, not normal. And see, remember, we had to start on this new model at the end of October last year, and so we were at the beginning, and this was right after the rising season was over, and it started going down just a tiny bit. And on October 29th, which was our first reading, it was 1885.5, and we're at 1901.0. And so 1885 and 1901. So that's what's that? 16 parts per billion higher. Yeah. Yep. So that's what I was saying last week. It didn't look like we were done with methane rising, and who knows? I mean, it could jump up some more this week. So moving on, for the full 487 millibar readings, for the full ones, for B and C satellites, the 14th average was 1913.25, giving us an increase of 3.25 this week. So 3.25 went up. That's not our highest on this reading so far. So far our highest was I think it was 1915 on the 16th. Well, there it is on the chart. But we might have something a little. So yeah, that was on the weekly reading. But then on the 18th it was 1915.25. That might be our high reading for this level. We're at 1913.25 right now. But still, we're moving up. And then on 1000 millibar level, which is surface level, the 14th average was 1849.0, an increase of 2.75 this week. So here's our increase here. And that is, I think that is our highest reading so far on this one. 1849. yeah, that's our highest reading. No, I take it back. Look at the 14th of September. We're 1849.25. So we're almost at the same little semi-peak there. So, it all did. This week will really tell us, if it goes up some more, then we'll have our peaks it'll probably peak out this week, is what I'm thinking, and then it'll start going down. So we'll see what happens. So, yeah, that's shocking, isn't it, to see, especially on that Met-Op-C going up 6.0 in one day. Wow. So here we go. Now we'll move to the CAMS methane forecast. This is from Copernicus Atmosphere Monitoring Service out of the EU. And our base time and valid time are both for Saturday, October 14th. Arctic area and surface level is where we're starting. So we've gone up, and so the data is for Saturday, and the forecast period is Sunday, Monday, Tuesday, Wednesday. And it looks to me like it's going up in the forecast period, especially if you watch here in the interior of the U.S. See the blobbiness there? Did you see that? Like right here from Texas all the way up to Canada. Look at that big blob. So that's on Tuesday that they're forecasting that. Okay, let's keep going. And we're seeing some higher readings across Russia. Okay, so let's just take this. Komsomolets is bubbling back up. Right here. See that? And the Scandinavian area, it's gone down. It's still in the red zone on some of it, but it's gone way down. Probably because it's in that cooler air. But, it just depends on the day, on whether it's high or low. And we're see these high readings coming across Russia in the interior. And the background colors are higher, is what I've noticed. Like when it pulses down to nighttime, the background color is higher than norm. It doesn't go back down to green. It's staying like in the yellows and oranges and some reds even see here in the U.S. See, so that's a sign of higher methane. We see higher background readings, and Alaska is picking back up in the interior. Here's Koktovik. And western Canada is still pretty high. Here's from North Dakota, that's billowing. And see, we've got high coming across Canada again. This is probably from the rain that they're getting. It's I'm thinking, yeah, it's going to go up quite a bit more this week, I'm thinking. California, pretty high. So there's that. Now we'll go to the North Pole view. Okay, Europe. Germany, you're filled up. France got a lot. And then, look, it's just blobby in this whole area. UK, Ireland, you're filled up. Here's Persian Gulf. See, it's filled up and spilling over. India, you're filling up, and see the high readings spilling over in the Bengal Bay. And China, you're filling up. This is, see, spilling over the coastline there. That's a sign of methane rising when you see just the blobs filling up on land and then the spillover. That's super high methane. And see the waves of the high readings moving out. And see the wave coming off of this China and Russia area. See, it's moved up into oranges and yellow. Same with this eastern seaboard in the US. Okay, now we'll go to the global view. And this darker blue, that's the 1840 parts per billion. Even with methane on the rise, we're seeing more of this creep in as the background color in the southern hemisphere. So that means, you know, if it's going down in the southern hemisphere, it's going up exponentially in the northern hemisphere, for it to be going up overall. It's not looking good. Okay, now we'll go to 500 HPA, and that's about halfway up in the atmosphere. We can see the heaviest is gathering over the Arctic and colder regions primarily, but we still have some heavy over China, China, Asia, and here north of India, also Pacific coming down. Look, we've got some heavy readings over the US as well, and heavy pretty far south. See, here's Madagascar. We've got yellows coming further south. And then total column. And the highest is from Japan, China, Southern Asia, and coming over towards India. We've got some hot spots over the Bengal Bay, Arabian Sea, and then hot spots. I mean, if we zoomed in on some of these, we would see hot spots over some of these land areas. Here's look at this hot spot. We rarely see it over the U.S., but this is on the east coast of the U.S., and this finger going out over the Atlantic. And here's a hot spot in the Pacific, just north of the Hawaiian Islands. And then all these reds too. So there's that. And then we'll just look at a couple of more things here. This is sulfur dioxide today off of CAMS. This is global, and we still have high readings near Alaska in the North Pacific there. And we had some high readings around in the southern hemisphere around this Antarctic plate line. I'm thinking that's from plate movement. See, we've got it here in the South Pacific, and here in the South Atlantic. Here, see, we're still high over Alaska, and it's holding here over the Arctic. This is at 500 HPA. And right up here, that's from Popocatépetl, but we have a new high reading down here near Panama, in the Panama region. Here's the North Pole view, and if we rotate and zoom in, we can see these high readings. I mean, really, the whole planet is higher in sulfur dioxide now. And it just hangs in the atmosphere once it gets up there. Here it is at 500 HPA. See, here it is, just north of Greenland, Alaska, and so on. And it does hang in the colder temperatures at 500 HPA. It hangs around a long time, I've found. Oops, I didn't mean to do that. And then, what did I do? Okay, here's the ozone hole over the Antarctic today. We can see it's still huge, and see it's gone off the page here. This is the Antarctic view, and so it goes up higher than what's in their image, and it's still huge. I don't think it's decreased in size, and we're still in the black zone here, right over the South Pole. So 5 layers down in the danger zone, and the sun is up. So this is very dangerous. And it should be starting to close up, or getting thicker at least, but it's not happening. It's just not happening yet. Here's the Antarctic ozone. And we can see this aqua hole over the North Atlantic, and then the green. Green, I consider greens holes too, but aqua is the next reading down. And most of the U.S. is in a shade of green, but Mexico too. So very thin, not good. Here's the global view. And see, then all the way across. And then the thicker is gathering here in the southern hemisphere, outside of the Antarctic ozone hole, and a little bit in the northern hemisphere. And I did take a couple of earthquake pictures today. 157 worldwide, and so that's a low number. Normally it's around 200 or 220 worldwide. And big action is over here in Afghanistan right now. There were 5 over here. There was a 6.3 near Herat, Afghanistan. This came in last night at 8:36 p.m. Pacific time. 6.3 kilometer depth. And then just 20 minutes later they had a 5.4. And then some 4s, aftershocks there. And that's all of those. So now I'm going to take a short break and come back, and we'll cover the sea ice portion of the show. Don't go anywhere. I'll be right back. Okay, I'm back, and now we'll move into the sea ice part of the show. And we're going to start with our slideshow from Climate Reanalyzer. I download these images every day to share with y'all. And we're starting with today, and we're seeing this is sea ice concentration and snow cover. So where you see the white on land, like here in the U.S., Western Canada, Northern Canada, Alaska, Russia, look, Norway, they're all see the white, that's all snow. And so there's also some snow on the sea ice, but it's kind of hard to tell. But anyway, here's what the ice looks like today, and it's inching out. This little bridge is trying to come back towards Siberia. We've got some fringe ice coming back here in the North Barents Sea and North Kara Sea, and so it's coming in around this east coast of Greenland. These tributaries are starting to get a little fringe ice, or some ice. So let's see what happened this last week. Here's where it was last Sunday that I was not able to show y'all. So we'll just click through and we'll see what happened since last Sunday. Here's the 8th. Here's the 9th, 10th. And so what we see here is some fringe ice. This is just wispy ice that came in like on the 10th, and then it looks like it's going away on the 11th. Here's the 12th, and here's the 13th, and here it is today on the 14th, and we can see that it melted. What froze out here melted on this west side, and we've got fringe ice on the east side. So that's probably from the air temperature that was warm. So there's that. And then I want to show you something. We're going to go to the Navy sea ice models next, but I wanted to show, this is the landing page I go to. It's Polar Oceans from the U.S. Navy website, and they've added a whole bunch of models here this week, and so as a result I decided to only record the Arctic and the Antarctic, and because I was recording Beaufort Sea and Ross Sea, and now look, we've got all of these. Well, we had the Baffin Bay, they started that a couple of years ago. Now they've got the Bering Sea, which is in between Alaska and Russia and the Aleutian Islands. They've got the Chukchi Sea, East Siberian Sea, Kara Sea, Laptev Sea. So those are all new. And so if you go to this landing page, like we can see the ice at the Kara Sea, sea ice thickness, and it's got all the different parameters like the others. Like here's the white is no ice, and so you can see where the fringe ice is starting to come back in, and see the color scale is the same. And so I just wanted to share that with y'all, that's all new. And so if I just want to hone in on one specific area, I will, but I'm not gonna keep recording a whole bunch of extras, so I'm just doing Arctic and Antarctic. So that's why. So we're starting with the Arctic sea ice thickness here for today, the 15th, and our color ledger is over here on the right, and we're still seeing blues and purples. The bright aqua is the 2 to 2.5 meters thick. That's the majority of the thicker ice. We're getting some reds and yellows and greens along this north coastline of Greenland. A little touch of reds over here. And see, the aqua is just holding. It almost looks like this is separating, though. But it is thickening up. We're seeing some aqua above here where it's thickened up. The North Pole is still about 1 meter thick, and here's our fringe ice coming back on the east side. See the light lavender and a little white around the coastlines. That's fringe ice as well. We've got that's creeping out on the extent, and not much regrowth here on this west side, but just a little bit. And it's still, with the whites, there's still a lot of probably open water and cracks and things where it's not fully concentrated. We can see these tributaries are coming back. We're seeing light lavender through these. Got a little bit of aqua in here. So, and here's a little refreeze in the North Baffin Bay, and a little refreeze on the east side of Greenland coming down. Here's the 30-day animation. This was updated to yesterday, so the data goes back 3 weeks, and the forecast goes out to this Saturday coming up, next Saturday. So let's see what it might do this week. So it looks like this is still like separating here, and it's sliding. You can see that it's drifting to the west here, but it looks like it's thinning out some more as it's moving down above Ellesmere Island there. See the dark so I think the sea ice is kind of struggling, and here it's thickening out a little bit here. So let's stop it at the end of the model. So here we are for next Saturday, and see the darker area. That's moved down. That's even it looks like it's moving down into the dark blue, which is even thinner than the dark aqua. So almost a hole opening up there. But we still got it right along the coastlines, the aqua, and then this little hump growing out. And we have this fringe ice, the little bridge coming all the way across to Siberia, or trying to, and freezing all the way across to New Siberian Islands and across to Siberia coast. And this open water is becoming less with the fringe ice there. A little bit more on this east side. Not a lot of change on this east side, but what's happening here just above Ellesmere Island is kind of bothering me. So here it is right now, or yesterday, and well, let's go back another week. So this is what we would have seen last week. This would have been Saturday a week ago. So let's watch it, and I'll just click through. So you can see it's sliding down and thinning out here. Look at this movement all the way along the coastline. That's the ice drift pulling it down. And see, we've got a crack here opening up. And here we are at the end. So, yeah, well, and unfortunately on NASA Worldview we don't have the nighttime layer anymore. So we're just going to have to depend on models to track the sea ice here in the winter. Here's the Antarctic for today. And the regrowth is, the melting, yeah, it is going down. And see how little ice is on this east side. It doesn't come out very far from the coast. We're seeing more aquas along the coastlines. Here's a little aqua spot showing up in the middle of the Weddell Sea. So a little bit of thickening going on. And here's the 30-day animation, and this forecast goes out to next Saturday. So, yeah, these edges are really starting to come in, and we've got, see the white along the coastline? That's the ice either pulling away or melting along these coastlines, which is not good. And so that means the water is warmer, that much warmer up by the coast. Here's National Snow and Ice Data Center for yesterday, Arctic sea ice concentration. And the brown is the median, so we're still well under that. The white areas are, the solid white means good concentration, meaning there's no cracks, that is solid ice. And we'll see that quite a bit where it's refrozen, where it's just a little thin layer of ice that's refrozen and it's solid, as opposed to the areas where it had been thicker ice and then it, the big cracks melted, and then it's harder for all of that to refreeze. Here's the refreeze so far. And this blue line is this year. This dotted line is 2012. And this angle is kind of dropping down a little bit now. It's not as going up as it had been. So, we're going to catch it. We're going to meet up with 2012. That's all there is to it. Here's the Antarctic, and the brown line is the median, and it's well under that. And here's the melting. This is a little pathetic chart. So here we are. This is this year. This line is last year, and it was below. It was record low last year, and now we're even more record low this year. So it did peak back here on September the 10th, and it's going down pretty steep there. Here's Greenland. They're still reporting on this. they'll stop at the end of October for the winter. And this is ice melt for yesterday. We're still seeing this little area just in on the north end. We've got a couple of salmon dots there, so that, but the rest of it has stopped melting. Here are the cumulative melt days for this year. So this X up here, that's where it's melting right now as well. And this is in the black, so this is 100+ days of melting for this year since January. So the white is the only area where it didn't melt this year. And so most of Greenland was in some state of melt at some point this summer. A lot of melting on this west side. See the purple, that's like 80 to 90 days of melting, the dark purple there, and moving on up, like the green, that's about 40 days of melting, like right in here. So, and so on. And here's the chart. We flatlined to meet up with the median. There was a little spike here. It was about 5% melt when we sat, I don't know, about a week ago. So there's that. Now we'll go on to NASA Worldview, and we're looking at the Arctic for today. And this big black circle, this is where it's dark from the sun going down. So the sun is very low on the horizon, and so all these areas are in the dark. A lot of northern Greenland, all of Ellesmere Island, most of Svalbard, all of Franz Josef Land, all of Severnaya Zemlya. That's all in the dark now. And so we'll look at this model, sea ice concentration, and we'll turn on the blue marble layer. This is the sea ice right now. So let's go back. Well, if we go back to the first, that's where we were the last time that I showed the Arctic sea ice. So here's where it was on October 1st. So we'll just click through. There's the 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, and here we are today. So we saw these edges coming out. These are thin, and see the white area that's concentrated where it's the thin ice. Just a little film that's formed so far. And these holes are filling in. And the regrowth here on the east side and along Greenland and in the tributaries and so on. And little hint of ice along some of these coastlines. And yeah, we'll see what we can see just with the satellite view. Then we'll start down here in the North Baffin Bay. And this is where the nearest strait empties out. Let's go back a couple of days. See, there's the ice, and a lot of, here's the ice there, and here's some fringe ice forming. That was on the 10th, so here we are today. Here's the fringe ice forming. This is a cloud, and so this is all still open here in these tributaries. Well, can't see much with the clouds. Got a little ice forming here, it looks like. Here's some ice, see the pieces there. So that's you know, what it looks like as it's starting to refreeze. And then here on the east side, we've got this ice on the east side coming down. Here it is. Here's the ice edge. See? Right there. Here's today. There's the ice. And here's the little foot on Svalbard and a little hand. And here is the Barents Sea. We're starting to see, let's see, is this ice or clouds here? Sometimes it's hard to tell, so we'll use this. That's clouds. See, the ice edge is over here, so we're seeing clouds here. Here's Novaya Zemlya. And here's Yamal Peninsula, and there's the Kara Sea. That's all open, all the way up to here, the north end. So we'll turn that off. Let's see, there you go. Here's some ice forming. Here's the Taimyr Peninsula. Let's see where the ice is. Right up to here. Here's the ice edge. So lots of clouds. Here's yesterday. You can see the ice. See? It's just coming in. So this is the Laptev Sea. It's still open. Here's the East Siberian Sea. It's mainly open. Let's see if there's any ice yet. Just a touch around the coastline. Let's see. they're counting that little wispy stuff. See, that's what I mean, like fringe ice. There's Wrangell Island, it's open. Here's the Bering Strait, that's all open. Here's Alaska. There's Barrow. This Beaufort Sea is still open. Now, we did see in one of the models, well, actually in Climate Reanalyzer, where the ice had come back and then it went away, just the fringe ice. But, it's too cloudy to really tell. These are clouds. That's the 12th. So here's the ice edge here on the 12th. Let's see. So, just lots of clouds. Can't see much. So here's some ice, a little bit, and I think that's ice. Maybe I'm wrong. Yeah, it's just barely coming out there. So there it is. That's about all we can make out up here. Now we'll hop to the Antarctic, and sun is up. It's still at an angle, but it is climbing higher in the sky. And here's the Western Peninsula. Down here is the Ross Sea. Here's the Ross Ice Shelf. Up here's the Weddell Sea. Here's the Weddell Ice Shelf. And we're going to start down here at this area with Pine Island Glacier and Thwaites Glacier. Now let me refresh and make sure I've got all the latest data here. And we saw that there's a lot of open water here next to the glacier, and it still is. See, here it is for yesterday, and these pieces, see, they're breaking off. But this ice had kind of moved in and now it's moving out. This is the Thwaites Glacier down here, and this was on the 13th, so this was Friday. This is one of our better views. Oh, look on the 12th. So see the ice there. So it had moved up towards the glacier, but now it's moving down and breaking up. Look at this, what a phenomenal view. So this tongue has separated from the Thwaites Glacier, and now look how it's just deteriorating. Look at this. And this is early in the season for this to be happening. Just way too early. Look at this. So that was the 12th. Here was Friday. Look at the movement. Look how much it moved out from one day to the next. Look at that. Huge openings there. And open water here. and this ice is just deteriorating. Now we've got a bunch of clouds and can't really see, but this is, it's really unbelievable to see it like this. Here's open water, open. So let's go through that again. So here's the 12th, where you can see all of this. Watch. To the 13th. Unbelievable. So how far up is this going to calve, I wonder? And it will. I mean, if it's like this at the beginning of the melt season, it will calve off, definitely. Okay, coming on around. Here's some open water. Here's the Western Peninsula. Now, right along the coastline are the Larsen ice shelves, what's left of them. This one is the Larsen Sea. That's a better view. Here's yesterday. Now, this had calved off, 2 or 3 years ago, but this is the sea ice that is refrozen there. But see the cracks, that's coming apart. Here's the tippy point. So along this Western Peninsula and then curving around is where there's quite a bit of aqua ice, or 2 to 2.5 meters. It's most of this. That's the thicker ice down here. Here's today. See the cracks. This is the Weddell Sea. And here's where that iceberg, where it calved off or broke off. Was it last year, year before last? We followed that one out to sea. Here's some clouds. There's our sea ice. Quite a bit of open water, huh? Here's the Brunt ice shelf. Here's where it capped off last year, right here. So here's the 11th, and see all the open water here, right up by the coast. That's what I'm talking about. Here's the Brunt. It's open, so let's click through. See, it's open. See that? That's open. You have to kind of learn to read through the clouds. I mean, the ice that's there is just barely there ice, but considering it had been open. And coming around, here's the north side. Here's this northeast edge. There's, remember the hole that had been here, and so that's breaking up there. Here's the Amory ice shelf. This is a great view today. Look at this. The whole thing. And here's the sea ice. A lot of open water, see? This is pretty thin there. Then coming around on this east side. See, it doesn't come out very far here. See the open water, the dark. And right down here, here's the Totten Glacier. Here's the sea ice. Pretty thin. See, it had been open earlier. That's the 11th. There's the 10th. So there's that. And then coming around, here's the Ross Sea. There's the ice comes down to there, and see the cracks, open water. Here's Ross Island, Mount Erebus, and the shadows are getting shorter as the sun is rising. There's the shadow. Here's the sea ice. But this had been open, and see, it just kind of pulls away from the ice edge. This is the Ross ice shelf here. This is pretty thin too. Then coming on around. See, here's open water. Well, if you can ever get a day without clouds, you can see what's going on. See that's opened up there. And here, see, through the clouds you can see it. Back to where we started, so there's that. And then let's look at earthquakes, see what else is going on. We've got 161 right now in the last 24 hours. It's still a low number, which makes me think that pressure's building. Let's look here in the Middle East. Here is one in northeast Afghanistan at 4.1. Here is one in Iran, just next to the Persian Gulf, 5.3 near Ram Hormuz, Iran. And then here, northwest Afghanistan, that's still the 5. So that hasn't changed since I took the pictures. So the 6.3, 5.4, and then 3 4s. And the last one was at 1:04 this morning, Pacific time. These are fours. Oh, let's look at New Zealand. You just had one, well, you had one on land, at 4.3 near Waiatara, New Zealand. 219 kilometers deep. So you probably didn't feel it if it was that deep. This came in last night at 8:15 p.m. Pacific time. There's a 4. Here's Tonga, 4.3. Fiji, let's see. Here's Japan, 5.2. Katsura. Here's one. This is just north of Hokkaido, 4.2 near Korsakov, Russia. Look, deep, 354 kilometers deep. And Alaska is showing 48. That's kind of an average low average. 30.4 in the Gulf of Alaska. Let's look. Here's one next to the Cocos Plate, 4.9 near El Salvador. Here was one just off the coast of Venezuela. Right here, 4.5. Guiria, I don't know how to say that. Venezuela. And here in the lower 48, we've got a cluster here. We've got 5 in the Reno area. Spanish Springs. And they're getting bigger. See, 2.2, 2.7, 2.9, and 2.4. That's all happened since midnight. And then out here in kind of central Nevada, here's a 3 near Kingston, 3.0, that's bigger, 3.5, and 1.4, so those are bigger. And we just have these clusters here and there. Almost nothing at Searles Valley Ridgecrest, so that's a little unusual. Now look over here at Ojai. We've got 6 here in this picture, and the largest was a 3.3, 3.7 right before that. That came in today at 12:50 p.m. And then 3.3, and then a 1, a 2, and a 2.7, 1.5. So Ojai is moving. But Southern California, not very many, only 17. That's a low number. So, you know, it just looks like pressure's building right now. And just, you know, a couple on this San Andreas Fault area. Now here, around San Francisco, down to San Jose, 5 today. 2.1 at 7 Trees was the largest. geysers, only 15. So that's a low number. So like I said, looks like pressure's building. And also it's the weekend, and the earthquake makers are at home on the weekend. You're not seeing quarry blasts on the weekend generally, and those do cause more earthquakes. But it looks eerily quiet from the Pacific Northwest all the way over through Yellowstone. See, nothing through all of there. Eerily quiet. Now let's look at 7 days, all magnitudes. Let's see. 1,610 earthquakes this last week. We've got a clustering here at South Sandwich Islands. Up here was a 4.5 in the Greenland Sea, and then 2 just south of Iceland, a 4.5 and 4.6 Reykjanes Ridge. Here's a 5.4 Central Mid-Atlantic Ridge. So these are all on the plate lines. Here was 6.0 just south of Australia, and 5.7. Look, see, this is all on this Antarctic plate line. I don't know why I always say Pacific when I mean the Antarctic plate line. Here's South Sandwich Islands. We've got 6 here. 5s and 4s there this week. Let's see what else. Here's the Fiji Tonga area, 4s and 5s. These are all 4s and 5s. And then, of course, here at Afghanistan. And let's see, they had movement earlier this week too. So 15 here this week. And earlier this week, starting on the 8th, which was last Sunday, 4.9, 4.7, 5.1, and then 6.3 happened on the 10th at 5:41 p.m. Pacific time, and then 5, and then 4s. So this has really been going on all week here. So, and this, this will cause damage. You get big earthquakes like that on land, that'll cause damage. And look up here. 5.0 Poland-Slovakia border. That's we normally don't see in there. That was pretty big. And then here was let's see, Aleutian Islands. We had some movement here. 5.6 was the largest at Nikolsky. And here in the lower 48. Look up here. Right up here. This one's about to come off the map. At 4.3 at Port Townsend, Washington. This came in last Sunday at 7:21 p.m. No, 7:21 p.m. Pacific time. And it's 7:21 right now. So that one is, it was white. It's just now coming off the map. That was the largest one in this area all week. See, there it goes. Just north of Seattle. We only had one on the Wandafuka plate, a 2.9 at the base. Not much movement there. Yellowstone. Pretty quiet, just a few. Here's a 3.3 Silvergate, Montana. That's a larger one. But look at here in the Spanish Springs area next to Reno. 17. See, this has been going on. Same area, 17. And this all started on the 11th with a 2.0. So the 2.9 so far is the biggest one, highest. Let's look at the geysers. Oh yeah. Look at this. They were rocking 162 right here this week. Let's see. Yeah, well, that's about right, I guess. Just depends. If we include this area, it's 199, so 200 in this geysers region. So if they have 20, 25 a day times 7, so that's almost 25 times 7, that's 175. So yeah, that's about average, but still, that just seems like a lot. Let's see, all the way down. The usual places. Oh, look down here. See, Honduras, Nicaragua. So some movement down here. This Cocos plate. See the movement there. So that's my report. Wait, nope, not quite. I forgot this big one. 6.0 in Argentina. This was on the 10th, 247 kilometers deep. So that'll buffer the shaking at Abra Pampa, Argentina on the 10th. So that's my report for tonight, and we'll bring this back to the spiritual perspective and continuing to read out of the book of Tobit. This is the first book in the Apocrypha, which were the books that were left out of the Bible. They were considered as part of the Bible to be in it, but then they were left out. Tobit chapter 11. After these things Tobias went his way, praising God that he had given him a prosperous journey and blessed Raguel and Edna his wife, and went on his way till they drew near unto Nineveh. Then Raphael said to Tobias, Thou knowest, brother, how thou didst leave thy father. Let us haste before thy wife, and prepare the house, and take in thine hand the gall of the fish. So they went their way, and the dog went after them. Now Anna sat looking about toward the way for her son. And when she espied him coming, she said to his father, Behold, thy son cometh, and the man that went with him. Then said Raphael, I know, Tobias, that thy father will open his eyes. Therefore anoint thou his eyes with the gall, and being pricked therewith, he shall rub, and the whiteness shall fall away, and he shall see thee. Then Anna ran forth, and fell upon the neck of her son, and said unto him, Seeing I have seen thee, my son, from henceforth I am content to die. And they wept both. Tobit also went forth toward the door, and stumbled, but his son ran unto him. And he took hold of his father, and he strake of the gall on his father's eyes, saying, Be of good hope, my father. And when his eyes began to smart, he rubbed them, and the whiteness peeled away from the corners of his eyes. And when he saw his son, he fell upon his neck. And he wept and said, Blessed art thou, O God, and blessed is thy name forever, and blessed are all thine holy angels. For thou hast scourged, and hast taken pity on me. For behold, I see my son Tobias. And his son went in rejoicing, and told his father the great things that had happened to him in Media. Then Tobit went out to meet his daughter-in-law at the gate of Nineveh, rejoicing and praising God. And they which saw him go marveled, because he had received his sight. But Tobias gave thanks before them, because God had mercy on him. And when he came near to Sarah his daughter-in-law, he blessed her, saying, Thou art welcome, daughter. God be blessed, which hath brought thee unto us, and blessed be thy father and thy mother. And there was joy among all his brethren which were at Nineveh. And Achiacharus and Nasbas, his brother's son, came, and Tobias's wedding was kept 7 days with great joy. Tobit chapter 11. So we're seeing more miracles, and we're seeing things work out now. And Tobias got home with his bride, and Tobit regained his eyesight, and now, they're going to be okay, it looks like. So I love you all, and I'm praying for you. Hope you all have as good a week as you can, that you're safe. I know a lot of people are in dire straits right now. The world is just teetering on the brink of just annihilation, it looks like. So if you haven't given your life to Jesus Christ, I recommend it, and be walking with him and God, and not be led astray by Satan in these dark days that are upon us. And so I love you all, and I'm praying for you, and Lord willing, I'll be here back next Sunday and give you another update. So God bless you. Go in peace, and I will talk to you soon. Good night.